Well, this is a video for the people who think that they understand quantum mechanics. And Feynman said that if you think you understand quantum mechanics, you don't understand it. Well, he's a Nobel Prize winner, so let's explore this statement today. So, what do you think quantum mechanics is? Quantum mechanics describe the behavior of tiniest of particles on atomic scales. Well, particles like electrons, photons, muons, Higgs boson. So, let's talk about the particle of light, photon. Fortunately, the photons and electrons behave in the same way, except that photon has zero rest mass. Why? Because they say that Higgs field does not interact with photons, and Higgs field is the field that gives mass to the particles. So somehow, for some reason, they interact with electrons. Some reasons they don't interact with photons, and we don't know reason. Science does not know the reason why photons don't have mass, and that's allowed photons to travel at the speed of light. So if you do know like why Higgs field don't interact with photons, let me know in the comments. So let's start talking about the particle of light. So firstly, Newton thought that light is made of particle. So he proposed a theory which is kind of suggested that light is particles. Then some Young's double slit experiment happened. Then we found out that light does behave like a wave. So Maxwell came up with a theory of light which says that light is a wave, electromagnetic wave, perpendicular direction. Then photoelectric effect happened, and photoelectric effect shows that light indeed behave like particles. So the thing is, what is happening? So and the quantum field theory emerged, which merged the wave-like behavior and particle-like behavior, saying that the light photons are present. Photon field is basically present everywhere, and particles are just excitations of that fields. So you know what you can observe, like we observe and we make theory according to that. Sometimes we make theory and observation happens afterwards. So observations and theories are kind of things are going on. So we do not exactly we don't intuitively know what is exactly happening on the atomic scale, because we grew up in the microscopic world, we grew up on a large scale. So our intuition is there for the what kind of thing, for the bigger things, not for atoms. We don't have intuition how atoms behave. So saying that light is a particle and wave both, it's saying like island is there, okay, and you can see that some dogs are of black color, some are of white color, some are of both color, black and white. So you will say that yeah, dogs are only of color black, white. You will say that, right? But the thing is, you never went out of the island. You never seen the that dogs can be of the brown color also. So thing I'm trying to say, we make observation, we make experiments, and from that experiment, that observations, we make theories. That theory should be consistent with observations and experiments. If that theory is not consistent with observations and experiments, we discard that theory and we try to make a new theory. If that theory does consistent with every observation we make, so we can say that we have a complete theory. So if we make observation about quantum world that is not described by quantum field theory, so we will say that quantum field theory is incorrect. So the thing is, theories can evolve, and the quantum world is so unintuitive. Like we can never know what is going on there. We can say that electron is behaving like a particle, and it is behaving like a wave, it is behaving like a cloud. But for some reason, and for our like body limitation, our body is not that tiny of a size, we can never go into that microscopic world. We can never for real we see that how does electron behave, how does particles on that scale behaves. Maybe there will be a theory sometime afterwards, but I don't think that theory is now. So that's the thing about quantum mechanics we don't understand. Like we are making observation, we are making experiments and all that, but what some other day we get some new experiments, new observation, how we will understand? Will our current understanding will will our current understanding will be like change? Yes, it will change. So how can you say that you understand quantum mechanics? We are in the process of understanding it, but for the things like classical mechanics, we do understand them because it is happening right in front of our eyes. We have intuition for it. But for quantum mechanics, it is not happening right in front of our eyes. We don't have any intuition for it. That's why Feynman said we don't know what is quantum mechanics because we have no intuition for it. Like you can see, like electrons behave like tiny magnets. They have spin, but they don't have a real spin. Like electron is not spinning like this. They are not spinning like because they are so tiny. How can they spin? They are so tiny. So the thing is, so for describing the spin, they called it quantum spin, not spin. A spin in classical world like this, and quantum spin is different, and we don't know how quantum spin look like. So we all study about theories like quantum spin is this, quantum spin is that, but in reality, nobody has seen quantum spin. Does it revolve? What is that quantum spin? That's why Feynman said that quantum mechanics, if you think you understand, you didn't understand it in the first place. So what about the guys who say that we don't understand quantum mechanics? They also don't understand quantum mechanics. This is so weird. That is the weirdness of quantum mechanics.